In this section, we're going to be solving systems of linear inequalities. A system of linear inequalities is a set of two or more linear inequalities containing two or more variables. It's kind of similar to solving systems of linear equations, except this time it's inequalities. So let's start with an example of identifying solutions of systems of linear inequalities. So we're given the system, so we have y is less than negative x plus 4, and y is less than or equal to x plus 1. And we are also given the coordinates 2, 1. We must plug in the ordered pair into each equation and see if it proves to be true or not. So let's start with the first equation. We have y less than negative x plus 4. We want to plug in the 2 and 1. So for 1, y would be 1 less than negative x, which is 2, plus 4. Let's simplify the right side. We would end up with 2, and 1 is indeed less than 2, so it is correct. Now we have to test the second equation. Y is less than or equal to x plus 1. Again, we plug in our ordered pairs, so y would be 2 less than or equal to x plus 1. X in this case would be 1 again, so 1 plus 1. We can simplify that. And when we simplify 1 plus 1, we end up with 2, and 2 is less than or equal to 2, so that is also correct. So 2, 1 is a solution to the system because it satisfies both inequalities. Now we're going to look at an example of solving a system of linear inequalities by graphing. We have the equations 8x plus 4y is less than or equal to 12. And we have y is greater than 1/2 x minus 2. We want to bring both equations into slope-intercept form. The bottom equation is already in slope-intercept form, so we only have to deal with the top one. So we want to isolate the y. So let's start by subtracting 8x from both sides. When we subtract 8x from the left side, the 8x cancel out, leaving us with 4y is less than or equal to 12 minus 8x. Now we want to isolate the y. We have to divide both sides by 4. This leaves us with y is less than or equal to negative 2x plus 3. Now that we have two equations in slope-intercept form, we can go ahead and graph them. Let's start by graphing the y is less than or equal to negative 2x plus 3. So let's go to the origin, go up 3 units. Then we have a slope of negative 2, so go down 2 units and to the right 1. Go down 2 units again and to the right 1. And we can draw a line now, but you want to make sure it's a solid line because it is a less than or equal to. And we can go ahead and graph this area. So we have, because it's less than or equal to, it's going to be below the line. In order to help not get confused with these types of problems, you want to graph the lines in probably different colors and make sure you're shading in different colors. Now we're going to go ahead and graph the second equation, which is y is greater than 1/2 x minus 2. So go to the origin, go down 2 units. Now we see that we have a slope of 1/2 x, so you want to go up 1 to the right 2, up 1 to the right 2. We can go ahead and draw the line with those 3 points. Make sure it's a dotted line because it's only a greater than, not a greater than or equal to. And because the equation is greater than, you want to graph above the line. So you want to graph this entire area above the line. Now that we finished graphing both the lines, we can see that there's a certain area of the graph where the two colors overlap. The area where the two colors overlap is the solution for the problem. Any coordinates within that area are the solutions to the problems. Now we're going to look at another example of graphing systems with parallel boundary lines. We have these equations y is less than 2x minus 3 and y is greater than 2x plus 2. We want to start off by going ahead and graphing both the equations, and they're both already in slope-intercept, so let's start with the first one. So the first equation, y is less than 2x minus 3. Start at the origin, go down 3 units. Now the slope is 2, so go up 2, right 1. Go up 2 again, and then to the right 1. And then using those 3 lines, 3 dots, you can create a line. Make sure it's dotted because it's a less than symbol, not a less than or equal to. And because it's less than, you can go ahead and shade below the line. Now we're going to go ahead and graph the second inequality, which is y is greater than 2x plus 2. Start at the origin, go 2 units up. Now the slope is 2x, so go 2 units up and 1 unit to the right. 2 units up, 1 unit to the right. And we can go ahead and use those 3 dots to make a line. Make sure it's a dotted line again because it's just a greater than, not a greater than or equal to. And because it's greater than, you want to shade in the area above the line. So we're going to go ahead and shade in that area. After we finish shading in that area, we can see that the two graphs do not overlap in any area. So this system has no solutions.